Hi everyone, so we have seen that when temperature increases, particles have more kinetic energy. They move faster. When they move faster, you're going to have more collisions. So as you can see here, more collisions than at lower temperature. This means that there's greater frequency of effective collisions. They will have greater tendency to collide with sufficient energy to overcome activation energy. Hence, rate increases at high temperature. So let's now look at the effect of concentration. Now, we're going to see that concentration is measured in mole per dm cube. That's the unit of concentration. But mole, or mole, M-O-L-E in full, this is amount of substance. So amount of substance is measured in mole, and dm cube is volume. So concentration is measured in amount of substance per unit volume. So this is concentration. So if we put it simply, if we look at these two beakers, here we have a concentrated solution. So we have lots of these blue particles per unit volume. Here you have less of these blue particles per unit volume. So this is a dilute solution. In a dilute solution, you have more water and less particles. And in a concentrated solution, you have less water, but you have more particles. So for example, this could be something that's 1 mole per dm cube. So this would be probably 3 moles per dm cube. So this is just the unit of concentration. We're going to get into more details about the unit of concentration when we do the mole concept. For now, you just have to know about the unit. So at high concentration, you have high rate of reaction. So you have a diagram here. This shows high concentration. If you have high concentration, you have more particles per unit volume. This is what we mean here. More particles per unit volume. More particles per unit volume means more effective collisions. You actually have greater number of collisions, hence more effective collisions, faster reaction. Low concentration, fewer particles per unit volume, fewer collisions, slower reaction. So try to answer this question. Explain why rate of reaction decreases as concentration decreases. Use the information here to answer this. Now, pressure will have the same effect as concentration. Normally, when we talk about concentration, we refer to aqueous. Aqueous means that it is dissolved in water. When we talk about pressure we are referring to gases, right? So when you have high pressure for gases, it has the same effect as high concentration. So high pressure, you have more particles of gas per unit volume, therefore you have more reaction. Here. So attempt these questions, question 1 and question 2, which relate to concentration. Effect of surface area. Here you have a small surface area of contact, which means that you can have 1, 2, 3, 4, 5, 6, 7, 8 collisions. So 8 collisions in comparison to here where you have the same mass of the solid, but if you look at the number of collisions, you have 15 collisions happening. So 15 collisions mean that, so increased number of collisions, increased number of successful collisions means rate is going to be faster. So surface area of contact is large when particles is small. So whenever you have small particles, for example powder, the reaction is going to be faster because you have increased number of collisions. Hence, frequency of effective collisions increases. Now, certain situations where you have extremely fine powders can result in explosions. For example, in flour mills, the air is filled with fine dust of flour, and fine dust of flour have very large surface area to volume ratio. A spark can cause the flour to catch fire. It can explode. Even in coal mines, the air around is filled with methane gas. So methane gas is highly flammable. So the concentration, here we're looking at concentration of methane gas is very high. And because the concentration is so high, rate of reactions becomes very fast. So it can easily explode with a spark. Try to work out these questions here. For the word equation, it mentions here that flour contains carbohydrates. So flour will contain carbon, hydrogen, and oxygen. These are the three elements present in flour. So exothermic reaction is the burning of flour here. So burning of flour means it's the reaction between flour and oxygen. So try to think what will be the products that you will get.